Welcome to the Autodesk Certification Overview for AutoCAD. My name is J.C. Malitsky, and I'm President and Owner of Digital JC CAD. I'm a former community college professor and a former department chair. I've been an ATC manager for many years, and I'm currently an ATC instructor. I've been using and teaching AutoCAD since 1985, and I'm co-author on several AutoCAD textbooks. I'm an Autodesk certified instructor for both AutoCAD and Autodesk Inventor, and I've taken and passed many AutoCAD exams over the years. Just too many to remember. But what's your goal? Your goal is to pass the AutoCAD exam of your choice. So at the end of this class, you will be able to develop a navigation workflow strategy for passing these exams. And we're going to look at some tips and techniques and even some tricks of how to do that, looking at what to study and what not to study. And we're going to run through a few PowerPoints for this first bulleted item. For the second bulleted item, we're going to do some hands-on, looking at some strategy for working through each type of question based on the objectives of that exam. Now, based on time, we can't go through every objective, but I think you'll get a good strategy of how to work through these different types of questions. Let's first look at the world that students step into when they complete their education. It is fast-paced and requires that individuals consistently stay abreast of the latest skills, particularly skills tied to technology. According to various studies from IDC, CompTIA, and Global Knowledge, training and certification has become a main reason for promotions, wage increases, and effectiveness. It is clear that career success and continued growth are a result of the investment individuals put into training and certification. While validating key skills will help with career advancement and success, what does it mean for the student, for a school, or for you? Schools that implement certification programs are seeing success in the form of a few different factors, like attendance, dropout and graduation rates, and GPAs. As you can see from this example school in Florida in the USA, the students in career programs that end in a certification have a higher GPA, they report less absences, and have higher graduation rates. Students are motivated by having real application for their skills and see the opportunities in front of them as they gain necessary skills and certifications. We're going to take a look at this slide from the bottom going up. Each exam is made up of multiple types of questions. The certified user exams have a 1-hour time limit and have individuals answering a combination of rich item types, such as hotspots, which are like point on the screen, or drag and drop. There's multiple choice questions or simulations, where they must perform tasks in a simulated environment of the software. The Certified Professional exam has a 2-hour time limit and has individuals answering a combination of multiple choice and performance-based questions where individuals work in both the software and test environment to show those skills. So on the Certified Professional, if you look on the slide, multiple choice and performance-based, which is hands-on. The Certified Specialist exam. And this exam is comprised of questions where a majority require you to use Autodesk InfraWorks and AutoCAD Civil 3D to create or modify a road and highway model and solution. You will identify numeric and text properties of the model and then type your answer into an input box. Other question types include multiple choice, matching, and point and click. That's that hotspot I was telling you about before. The exam has a 3-hour time limit, but in some countries the time limit may be extended. So let's take a look at how we would put this all together. So how does one get ahead and start to take advantage of what Autodesk has to offer? We take a look at these 6 factors. There are easy steps to get started. From selecting which certification makes sense, which we just discussed on the previous slide, to what training for that certification and practice skills to finally take the exam. So again, this sort of is your guide to where you would need to go. With that in mind, let's take a look at the roadmap, and this is number 2 from above. What I would want you to do is go to autodesk.com/certification and take a look at that website and read about everything that the certification exams entail. Very good starting point if you've never taken one of these before. And for those of you who have, please go back there and revisit this website. But also you can look at the certification options. And again, we just went over those 3. But I do want to call your attention at the bottom of the slide of where you can select the certification options and look at the specific options for each Autodesk certification exam. So here's my disclaimer. The data sets that we're going to use in this presentation are not used in any of the AutoCAD certification exams. And no AutoCAD certification exam questions will be used or discussed. This class is really designed for you to walk through as many objectives as the time permits, highlighting those time-saving tips and techniques for your study and preparation. There's no guarantees that taking this class you'll pass any of the AutoCAD certification exams. But I hope you do. So let's get started. Let's look at the navigation workflow strategies for those tips to navigate through the exam. First of all, the similarity between the user and professional exams is there. So it helps you if you take one first or the other one first to go back and forth. Also, let's review about the hands-on, the skill-based questions in the professional exam. We need to know AutoCAD and how it works. Then the knowledge-based questions that were in the professional or the user exam. Those multiple choice, drag and drop, and those hotspot, which is point and click. So again, typical multiple choice types of questions and drag across to find the answers to the questions. In the user exam, we have the simulation-based questions. Read the question. It's a step-by-step procedure. Follow it. Some other tips. When you're taking the exam, read all the question. Just don't read part of it. Don't read it fast. Read it very slowly. These are tips for not only navigating through, but these are good test-taking techniques. Look at each question to identify those key words. Sometimes those key words could be just trim and extend and stretch, but take your time to slowly read the question. And then when you read the question, read all of the answers. I cannot tell you how many times when I'm proctoring an exam, people come up to me after the exam and say, well, I put the right answer down, and they tell me the answers. I said, well, that's not all the answers. Well, they never read all of the possible answers, so read those. There's absolute determiners. Now, you won't find the false ones, like in a test question. If it's written poorly, you'll see the words never or none. Usually those are false. And on the opposite side, the true side, you'll see may or usually or generally. However, I only put this in this slide to call your attention to that because overall the questions in the AutoCAD exams are very well worded. But this is a tip for those of you who have a lot of experience. You may not need to do all the tasks. If you read all the questions and the possible answers that it could be, let's say for a multiple choice, or you read the question for a hands-on, those tasks may not be needed for the hands-on, right? You can maybe skip a few things. But if you're unsure, do exactly what the question says in the order the question asks. That's super important. And look for common errors as distractors. Those of us who've been taking and writing exams for a long time, we know that if you use a multiple choice question, there's going to be one or two definite tough distractors to take us off the topic at hand. Find those, eliminate those. So if you have a question with 4 possible answers, try to eliminate 2 of the distractors right off the bat, and now you have a 50-50 chance of getting the question correct. And this is the one that I actually have a hard time with because I read the question too fast and I miss whether it's a positive or negative phrase. For example, like which statement is true or which statement is valid or which statement is invalid or which statement is false. Many exams are written this way. And I'll be quite honest with you, sometimes I read the word wrong and wait a second, these are all true or no, or these are all false, and then I have false, and I have to go back and re-look at what I was doing. So take your time and look for phrasing in that question. For the hands-on portion of the exams, see what it is you're going to do in the graphic. Read the question and look at the tools you'll need to solve the question. That's common. It's like common sense type of thing. But look at the question, look at the picture, figure it out, and then go from there. Take your time, go slow. On a multiple choice question, usually the question will provide enough information to give you the answer, which it should, but think of what the answer could be before you look at the answers. Because remember I just said, go ahead and read all the answers, but there's one step in between that. Read the question, think about the answer, I got the answer. Pause and go look at the possible answers that are there. And hopefully you'll see the matchup. But again, read them all. For the hands-on portion, if you have AutoCAD up and running and you have the exam up and running, you're going to have to Alt-Tab to go through the exam back and forth to be able to do that, to see the exam, to see the test questions, to go to AutoCAD, to go back to the exam. So Alt-Tab on a one-screen system. But also you're going to need to pull out the answer from properties, from the command line, from wherever AutoCAD gives you the answer. So we're going to do a Control C, Control V, or right mouse button, right click, copy, right mouse button, paste into the input box. So in other words, from AutoCAD into the exam. But a word of caution. When you do that, make sure you look at the answer that you've pasted into the input box. I cannot tell you again and stress again how many people have come up to me and said, I know I put the answer in. Well, what they did is they pasted in the answer from the last question and didn't realize that's what they did because their Control C, Control V wasn't right. And some people said you should use right mouse button, copy, right mouse button, paste to do this. So work on that technique and double check your answers. If you're taking the exam, and you know the answer, answer it in the input box. But if you don't know the answer, you read the question, you don't know how to do the hands-on portion or the multiple choice portion or a drag and drop, just skip it. Just go right on, forget about it. If you're not quite sure of the answer, but you maybe understand a little bit, now this is the answer. So you sort of put it down, but you're not quite sure. In the professional exam, you can put a mark and mark that answer to come back to it later. So this is a strategy. Answer it, skip it, mark it. Because there's a time element. We only have so much time to go through each of the exams. So the key is that at the end of the exam, you will be able to review all the questions if time permits. And you get a little chart, and this is on the professional exam. There's a little table or chart at the end that shows you the answers you've put in, the incompletes, meaning the ones you just didn't answer, or the ones that you mark. The questions that you've answered, for the most part, don't go back to those, because if you change them at the last minute, how many times have we got that answer wrong after we've put it in right? Again, that's a good test-taking technique. Just leave it alone. From that table or chart at the end of the professional exam, go back to the marked ones. Go back to the incomplete ones, the ones you didn't answer, those questions. But answer all the questions. I know people that have missed the exam by 1 or 2 questions, by 1 or 2%, because they didn't answer all the questions. They got stuck, and they spent so much time trying to answer a question instead of going through the exam and then coming back. That's a key and a good test-taking technique. But leave yourself some time at the end if you have time. And for those of you who are real quick and you have a lot of time left, review, review, review. And at the end of the professional exam, this is just an example, press the end button and you're done with the exam. But the key is do all the questions of the exam as you navigate through. So what do we need to study and to prepare for the certification exams? The very simple answer is the objectives. That's it. Go back to the AutoCAD certification website and go to the certification options for the exam that you want to take and study the objectives. That's the key. That's the roadmap of where the questions are going to come from. But once I know about the objectives that I need, I go into the AutoCAD help menu. I launch AutoCAD, go into help, and I start to look at the objectives to the commands and features inside of help. So the example we're looking at is layers. I read all about layers. Again, how to create them, how to manipulate them, how to make changes. What's a transparency? How do I manipulate the viewport layer controls? You know what I mean. That's what you need to do for every objective. Go to layers and review, whether you're a seasoned veteran or a new person just using AutoCAD for a few months. Start with help. Next, go in and look at the Autodesk certified courseware that is being used for AutoCAD. Or go to other training manuals or textbooks that you have or have used in any classes that you have been taking over the years. Again, relating back to those objectives. Common sense things, right? And the last thing that I do every so often is I'll go on the internet and I'll look at different videos or other lessons that other people have posted about taking exams, about AutoCAD that meets the objectives of the exam that I'm looking at. So if you look at these 3 bulleted items, but start with help and guide it off those objectives, I think you'll be on your way. The hands-on exercises addresses our second objective. And for the topics we're going to look at, based on the time that we have, is we're going to look at rotate and rotate with reference angles. We're going to look at different variations of grips on different objects and how to calculate area using the area command in hatch, as well as hatch objects and editing those objects. We're going to look at different objects and how to apply fillets, and also looking at the varying differences between polylines, how to edit those, and to make modifications. We're going to quickly look at dimensioning, dimension styles, and how to apply the annotative property, as well as looking at offset and finding area. We're going to take a look at blocks, just how to insert them, and then how to make a quick change using the block editor, and look at isolate and hide, hatch separate, and creation of selection sets. We're going to close off the hands-on exercises by using the inquiry commands, such as distance and ID. Let's start off the hands-on portion of our presentation today by looking at rotate and rotate using reference angles. I have 3 examples for you. In the example on the screen now, on the right-hand side, we have an object that has 2 holes, and on the left-hand side, it's wrong. We need to rotate that one circle over at 128 degrees. So I'm going to go into the rotate tool, and I'm going to select the circle to rotate. To specify the base point is going to be the center of the hub projection, and my angle that I want to rotate at will be 128. However, I need to call your attention to the bottom of the command line at the bottom of the screen where I select the word copy. I'm not going to press C, enter, old school. I'm going down and selecting the word copy with my left mouse button click. And now I'm going to go ahead and select 104 degrees, not 128. Why did I select the 104? Because I'm already at 24. So 24 plus 104 equals 128. In our second example, same thing, but in this case, we know that in the left-hand side, we're sort of missing stuff. We don't know what angle that is. We know we've got to go to 128, but we don't know what that start angle is. So in this case, we're going to have to use copy and a reference angle. So I'm going to start with rotate again and select that circle and press enter. My base point's going to be the center of the hub projection like we did before. I need to come down and select the word copy, and then I need to select the word reference. And now AutoCAD is prompting me to establish that reference angle. Well, what I don't want to do is I do not want to use the red center line at that angle. I don't know if the person who designed this originally put that center line in at that right angle, but I know if I reference from the center of the hub projection to the center of the circle, that will give me that reference angle. Now what angle do I need to go at? Well, the answer is 128. 128 because I established a reference, and now I need to push that over and copy that over to 128. In our third example, you can see on the right-hand side, this assembly, that top part is rotated at the wrong angle. I need to make it parallel to the line at the, looks a little bit like 120 degree angle. So I'm going to come in here and I'm going to rotate that top part of the assembly. When it prompts me for the base point, I'm going to select the center of the circle as my base point. And now I need to establish a reference since I don't know what any of the angles are. So I'm going to pick those two endpoints of that object. Now you can say, well, wait a second, that doesn't seem like it's orientated quite right. Well, if I go back down to the bottom of the command line, I can select points. And I'm going to establish those 2 points to take that part and rotate that part exactly over to where I want it. So there's another good example of using reference angles when rotating. Let's move on and take a look at how we can use grips. To grip or not to grip? And that's the question. Let's take a look at using grips. First of all, there's 2 basic categories of grips. And when I select the line, and we're all familiar with grips, the warm grips that are located on this line have 3 different grip locations. The middle grip location, as I select it, becomes a hot grip. And as I call your attention to the lower left corner of the screen in our command line, and I hit the space bar to toggle through the various grip options, these are called grip modes. And these are the old school grips that have been around for a long time. And I do want to call your attention also to the command options of those commands, or some people call them subcommands. But those command options of base point and copy and reference, you can see the similarities between each one of those editing tools that we can use using grips. So if you've used grip before, you've got the understanding. If you're fairly new to grips, give it a try and work through using these editing tools or these editing grips to edit various objects. So those are called grip modes. If I hover over the end of a line, for example, I get a multi-function grip. That multi-function grip, of course, will give me the length of that line, but also give me some options where I can manipulate that line. So if I wanted to lengthen that line, I could go in and select lengthen and then type in that length and distance I want to lengthen that line. And I just typed in 1 unit, so it lengthened that 1 unit. So again, the manipulation of those grips. Same thing with the circle. If I select a circle and I select the center of that circle grip and I cycle through the different grips, the command modes or the grip modes are a little bit different. But you can see as I go ahead and use some of the multifunction capabilities of different types of grips. Let's take a look at this object. What kind of object is this? Well, it's a polyline. And a polyline, again, if I hover, gives me multi-function grip capabilities of a polyline. And different locations give different multifunction grip capabilities as I select those. So you need to walk through those. What do we have down here? This looks like an arc. Yes, it's an arc. And again, you can see the different multifunction capabilities depending where I hover over any of the grips. Now in this case, when I select the center of that, that goes back to my grip modes. And as I can cycle through those grip modes by pressing the space bar. This object here, what is this kind of object? Oh, this is a spline. So a spline has different types of grips also. And you can go ahead and make modifications and changes. Let's take a look at one more. And of course, that's dimensions. If we take a look at the dimensions that we have here and hover over the different grips, again, we have different multifunction capabilities in these grips. So again, the two types of grips are multifunction grips or grip modes. So your challenge is to go back and study all the different objects similar to what I did and make sure you understand the different functionalities of all the different grips on different AutoCAD objects. In this example, we need to use the area command to find the surface area of this full sectioned part. And then in our second operation, we're going to go in and apply a hatch pattern. So I'm going to go in and I'm going to start with the area command. I'm coming down to the bottom of the screen in the command area and I'm going to select Add Area Object. And I'm going to select that polyline outside boundary that represents the teeth of this part. So I did an Add Object. I'm going to press Enter and go down to Subtract Area Object and select the three circles and press Enter. And when I do that, my total area of the part is 19.4586, which matches what is on the screen. So now I verified that that area is correct. My second operation is to go in to apply a hatch pattern. So I'm going to go into hatch. I'm going to select that point inside the boundary, press Enter, and wow, that's terrible. It's not the way it should be done. The islands are not being detected. I know I've got to make some changes. This is a real bad CAD. So I'm just going to erase it. I'm just so frustrated. And it says that there's some edits, some non-hatch boundary, non-associative boundaries must be off too. I'm just going to go and start over again. But when I go into hatch it, I notice that on my hatch creation ribbon, associative is not turned on. I need to add associative on because that center circle diameter needs to change. I'm going to go down into options and I notice that my island detection is set to ignore. I need to change that to normal. So associative on and normal island detection. And I go ahead and pick that point and press Enter. So now let's see what the area of the hatch pattern is. So if I select the hatch pattern and I look in the Properties palette under Area, I notice that the area is 19.4586. So here's one of those tips and tricks about finding an area of an object. We could use the area command, but in this case we can also use the hatch command and then find the area of the hatch pattern. So you have a different option. Now I need to change that center bore diameter. So that hole that's in the center is at a 0.807. I need to select that, and I know that I need to change that to 1 to change the diameter. Now I know my area is going to change. It is associative. I go ahead and select the hatch pattern, and I do know that the area, of course, will get smaller, and it's now at 18.3629. So we looked at a very good implementation of finding areas, how to use the hatch pattern, and then how to edit the hatch pattern. In this example, we need to apply fillets to various objects inside of AutoCAD. Now I know you've used fillets before to create a round or a fillet, depending on what type of part you're creating, but let's walk through some different scenarios. I'm going to go into the fillet command, And I'm going to set my radius. I'm going to go down to the bottom in the command line, set my radius to 0, because what I need to do is to finish off this exterior wall. And there I've filleted that object with a radius of 0. I'm going to come over to these objects, and this object, this is just a series of lines, where this object is a polyline. So we're going to look at a couple different methods of how to fillet this. So if I go into fillet, this time I'm going to go down to the bottom and set my radius to 0.5. And I'm going to go in and start to fillet these objects. And I'm going to hit the space bar to repeat the command. And I can go in and apply those fillets one at a time to be able to do that. In the case of the polyline, I come down to the bottom, select the word polyline on the command line, and I'm going to go ahead and just select the polyline, and the polyline will fillet all 4 corners at one time. So a better workflow depending if you have lines or polylines. Well, what about an open polyline? Yep, that's an open polyline. Can I do the same thing with an open polyline? Come down to polyline, select polyline, select my polyline, and the answer is yes. It comes out exactly the same. Let me undo that and go back in and put a fillet, but this time I'm going to select one leg and then the other leg to get that 1/2 inch fillet. Hit the space bar to go back into the fillet command, reset my radius to 1.5, and then fillet these 2 lines. So there we go. So on a polyline, we can have varying fillets on the corner or do the polyline all at the same time. Let's take a look at a couple other examples. I'm going to go in and fillet and set the radius back to 0.5 so it's easy to see. And I'm going to fillet these 2 lines. Can I do that? The answer is yes. That's good. The lines over here, the magenta lines, are rays, R-A-Y-S, array, a semi-infinite line. Can I come in and fillet these rays? Let's take a look. I'm going to come into fillet. My radius is set to 0.5. I'm going to select that ray and that ray, and it does work. So because somewhere they intersect, I can go ahead and fillet those. Let's take a look at these 2 lines. I'm going to fillet these 2 lines. So I'm going to go into fillet. I'm going to select one line. The radius is set at 0.5. Select the other line. And well, wait a second. Let's take a look at what the command line says. Lines are non-coplanar. Well, that's why they didn't fillet. Those lines are in 3D. Those are 3D lines. They just look from plan view or top view that they intersect, but in reality, they do not in a flat 2D plane. Let's take a look at X line. These are X lines. Those are infinite lines. The ends of the lines just go on to infinity. So they're parallel. So can I fillet these 2 and see what happens? No, I can't do that. The line must be a line or a ray to be able to fillet those. So I can't fillet X lines. Let's do, it looks like we've got one more on here. Let's see if we can, these are 2 lines. Let's see if we can go in and fillet these 2 parallel lines. So I'm going to come in and put a fillet, and I'm going to fillet that one with a radius of 0.5 and that one. Yes, I can. I can fillet parallel lines. And there they are. So regardless of the radius, it takes the offset spacing and caps the ends of it to create a fillet. So the key that I wanted to show you was that depending on the type of object you are filleting, the workflow varies. Polylines are a unique object in AutoCAD. They're one object. So let's take a look at creating and editing polylines. So when I come in to draw a polyline, polyline prompts me to specify the start point. And then it will give me multiple command options or subcommands. And as I'm drawing this polyline, you can see that the width is way too wide. So I'll come down to the command line at the bottom of the screen, select width, and maybe I'm going to change my width to 1/8 of an inch for my starting width and 1/8 of an inch for my ending width, 0.125. And I can go ahead and create that polyline. But also I can go in and create arcs in that polyline. I can select the radius. I can go back 2 lines, select the word line, and then come down to the bottom and select Close. But I need to edit that polyline. So I can come in, and if I select that polyline, I'm going to just double click, and I can get a menu that'll pop up, a context sensitive menu, or again looking at the command line to make the changes. So maybe I'm going to spline that polyline or fit curve it to go through the fit data points that we have. So if I'm going to select this, you can see the fit data points on that object. So if I hover over that grip, it's multifunction, I can go in and change and modify any of the vertex or tangent directions that I would like. If I go ahead and double click on that again, that polyline, and I need to decurve it. Now maybe I'm going to spline it. Let's just take a look at how a spline looks. A spline not only can have those fit data points, but it has control points. So I can take these control points and pull the control points however I want to modify that P-line as a spline. I'm going to double click again, and I'm going to go into decurve that polyline to bring it back to the location of decurve. Erase that polyline, start another polyline. Start with the width. I can change the width back down to 0 for my starting width. For my ending width, I wanted 0. Oh, this polyline's all screwed up. I just don't like the way that came out. But it has different start widths and end widths. If I go in and edit that, I can change the overall width of that for all segments back down to the original 0 length to get my polyline. On these objects on the right, of course, is a rectangle and a polygon. And rectangles and polygons are polylines. And I can go in and again use the multifunction grips to make any modifications or changes that I would like. If I go to the grip in the center, I can convert that to an arc and change that arc to a different radius for that polyline. I can go back in and, you know what? No, I don't want that arc. I'm going to convert it back to a line. So using the multi-function grips give us the ability to modify and change things. So let's take a look at this polyline. Wait a second, that's not a polyline. That looks like a line. So we have a line and an arc according to what properties is telling me. So I can go into the p-edit command or polyline edit, p-edit, and I can go ahead and select that line. And it's asking me and prompting me, do I want to turn that line into a polyline? Well, in this case, I do. So I'm going to press enter. And now I'm going to go into join and join that line to that arc and press enter and press enter. Now, what do I have? What I have left is a new polyline. So I was able to join a line and arc to create a polyline. So looking at that sequence. So what do you need to do here? I know you've used polylines in the past for many of the jobs and projects you've been working on. Do go into help and take a look at how do you create, edit, join, spline, fit curve, and decurve polylines to prepare for the certification exams. In this example, we need to apply a few dimensions to the simple part, modify the dimension style, and use the annotative property for dimensioning. I'm going to come in first and start a linear dimension, and I'm going to put a linear dimension by hitting the space bar, selecting that vertical line, and placing the 5-unit dimension. I'll go in and do another linear dimension from that endpoint to the endpoint of the line and place that dimension. Accordingly, I need to continue dimension all the way across. So I go into continue dimension, place the continue dimension, and then finish off with a linear dimension for proper dimensioning technique. And there it is. But wait, maybe we don't want to do continue dimension because it creates a cumulative error. So I'm going to come back and maybe I'm going to baseline dimension this. So I'm going to go ahead and select the object for baseline and then continue baselining dimension across this object. And there it is. If I missed a dimension, I can come and use my grips and replace the dimension. Again, you can see that I have the ability to modify my dimensions using grips. And I think I'm just going to put that final linear dimension in along the top. You know what? Let's edit this. I don't like my dimension space on here. So I can go in and edit this by finding what the command for dim space is. There it is, adjust the space. So I'm going to go ahead and select the object. I just don't like my spacing. And the second object and the third object and the fourth and the fifth and sixth. And you can see that the spacing's way off. So I'm going to select a value of 0.375. So it's a little bit wider than I need. So I reset that spacing. You know, I better reset the dimension spacing over here also to get the spacing here the same. So it looks very nice. 0.375. Well, you know what? That's kind of close. I'm going to use my grips. I'm just going to pull that out a little bit. There it is. So now I have a nice clean readability on this drawing. So baseline, continue, editing with grips, and editing with dim space. Well, let's see what else we need to do. I noticed that this part needs to be on an A-size sheet of paper, but boy, that scale is way off. So I'm going to go ahead and set it to scale to 1:1. And when I set it to 1:1, I realized that that scale it's just a little bit too big. So I better set it to half. So I'm going to come down and set it to 1:2 to make that a little bit smaller. I also know that what I call my two easy buttons, my annotation visibility in the lower right corner and add annotation scales is turned on at a scale of 1:2. So I better jump back into model space and go ahead and set that to 1:2. But by doing that, did you notice that the dimensions did not change? So I need to go into my Dimension Style Manager and change that. So I'm going to go into Dimension Styles by hitting the little angular arrow. That's the dialog box launcher. And I notice that mechanical is not annotative because it doesn't have that triangle. So I'm going to modify that. And I'm going to go to fit, and I'm going to change that to annotative. What's my primary units? 3 points past the decimal. That's okay. What does my lines look like? Right by the right color, everything looks okay. So the only thing I really needed to change in this case was the annotative property. But what you need to do is to take a look at the different types of picks that you can do per tab. So walk yourself through. You know, I've decided I'm going to change it to the mechanical text style just for today. So there's my changes. It's all mechanical. I'm going to go ahead and close that. And notice how the objects changed and how the new text style was applied. But let's see if it's really annotative. So let's go to 1:4 and see if it all changes. Wait a second, it didn't change. Oh no, I've got to go back to 1:2, nothing's changing. I better turn on my properties. So I'm going to go into properties. I'm going to turn on my properties and I'm just going to select one of the dimensions to test it. And sure enough, they did not change. So I can make that annotative, yes. So now it's an annotative property. So I know I changed everything to annotative. It didn't update for whatever reason, but I have the ability to go back in and make that change. So why don't I just go in real quick, and I know I'm doing these very slowly, but you get the idea of what I'm doing here. I just need to go in to select all of those dimensions, go into properties, I know it varies, and now make them all annotative. That's what I need to do. So I've made that change. Now let's go back to our A-size sheet of paper, take a look, and let's go back to 1:1, see how that looks. And now let's go to 1:2, and notice how the dimensions and text, everything has changed accordingly to fit nice in that A-size sheet of paper. So we got quite a bit done in just a short time. We put a few dimensions on. We've gone from continue to baseline. We changed our dim spacing. We modified our dimension style and added the annotative property. In this example, we have an object that looks like a race course, or it could be a sophisticated extrusion. But I need to go in and to find the length of this polyline. So I can find a total length of 242.34 as our properties palette shows us. We also know the area, but maybe if I change and I modify the polyline by pulling that grip location and then regenning the drawing, you can see that the area changes automatically. And I've linked this to a field, so that's why the number changes. But I need to offset to the current layer. So I'm going to go into offset. I'm going to set my distance at 1.5, select my object outside on the outside, and there it is. But why did it go to the current layer? Well, let's step back for a second and see how we would do that. If I go into offset, the first thing that I need to do is to come down at the bottom in the command area and select layer and select the current layer. That's what I need to do. So it goes to the current layer, which is the section layer. Set my offset distance at 1.5 and offset outward. How long is that polyline? Well, if I select it and go into properties, I notice that the length is longer at 252.92. But then what is the area between the two polylines? Well, we learned that before in our hatch example. So if I come up to draw a hatch, I can select inside that boundary area, pick inside that boundary area, press enter, and there I've hatched that information. Now what is the area of that hatch? Well, if I select the hatch pattern, look at my properties palette, it will tell me the area is 371.35. So here's a real good use of finding an area between two offset polylines. In this example, we have a very densely packed drawing, a civil drawing, that I need to work on. And I need to hide this area. It's not supposed to be part of this drawing right now. So I can go in and create a window over the area, or I can create a crossing and use different selection sets to do that. In this case, I'm going to come in, highlight the area with a window, do a right click, isolate, hide, and I can hide objects from the drawing. Instead of using layers and layer controls, I can use isolate or hide. So let me undo that. No, that's not really what I want to do. I just want to do the opposite. I'm going to create a window over the area I want to work with. Right click, isolate, isolate, because that's the area that I want to work on. But I can go in and hide this little part of the subdivision at the end of the cul-de-sac. So I'm going to go in here and I'm going to create a window. I'm going to right click, isolate, instead of isolate, isolate, I'm going to isolate, hide. So I want to remove those objects. But I realize the hatch pattern did not go away. And when I select the hatch pattern, I know that this hatch pattern on the opposite side of the cul-de-sac is also part of that. Well, one of the things that I can do is I can select that hatch pattern, come into my options, and go to separate hatches. So by going into separate hatches, now this hatch pattern stands on its own. So if I go in and select this again and do a right click, isolate, isolate objects, I can go in and isolate those objects again or hide those objects. I want to hide that object. There it is. So now those objects are hidden. And now I can work in this area if I don't need that information. But wait a second, I want to bring that stuff back. Well, what I can do is, and I call your attention to isolate end objects isolation. That'll bring all the objects back. Or if you look in the lower right corner of my screen, that red light bulb, I'm going to go ahead and select it, unisolate objects. And it will end the object isolation and bring everything back. So a better usage of isolating objects or hiding objects instead of using layer controls. But I realized through my engineering changes that this whole area needs to be erased, or just the building needs to be erased. Well, I need to create a selection set to erase just the building. Well, one of the things that I can do is I can come in and use erase, and I'm going to do a WP for a window polygon. And I'm going to come in here and create a window polygon over just the area that I want to erase and press enter. And when I press enter again, the house format goes away because I used window polygon. If I went into erase and I did a CP, a crossing polygon, I can come in here and do a crossing polygon, except the problem that I run into by doing that is I take too much information away of the format of the way the building sits. So erase, WP for window polygon, and just go over and select just the objects that you want with a window polygon. Press enter, enter, and the house format goes away. So there's a good example of using selection sets. So what you want to study for the exam then is isolate and hide the differences, a little bit more about hatching, even though we've already gone over hatching in a previous demonstration, but also how you can create selection sets. As we start to build a new architectural drawing, I need to insert a sink into this tool room, and I've created a sink block. So I'm going to go into insert, and I'm going to insert the sink block based on the coordinates that I'm given. It's 142 feet 9 inches in the X direction, and then in the Y direction it's 32 feet 10 inches. 32 feet 10 inches. And I'm going to go ahead and click OK. Well, I know you've inserted blocks before, and that's pretty easy to do. But the next thing that I need to do is I've got an engineering change order that says, you know, you need to modify that block. So I'm going to double click on that block, and I'm going to click OK and bring the block into the block editor. And as soon as I do that, I notice that my authoring palette comes on the screen, and I can make some changes. Now these all have to do with some of the dynamic blocks or visibility that I can create, or I can come in and establish a new base point if I needed to. That's not what I really need to do. I just need to make a change here and move this sink up a little bit. So the drain goes here, this back part of the sink comes over a little bit like this. So it's a little different change, a little different shape of what I'm doing. And then go ahead and close the block editor. And I'm going to save those changes. Now I just noticed that also that the sink is in the wrong location. So what I'm asked to do is to move the sink straight up 4 feet. I'm going to use grips for this. I'm going to go ahead and create a hot grip. And I'm going to hit the space bar until I go to move. And I'm going to move it straight up. And I'm going to type in 4 feet, enter. So I moved that sink 4 feet from its original location. Now I need to know where in this drawing this sink is located. So I'm going to use the ID command. I'm just going to type in ID. And I need to find the insertion point of the block. Where is this block inserted as we've moved it? So what I can do is come into the insertion point of the block and select the block. And there's the insertion point of that block. And now the distance is 142 feet in the X and 36 feet 10 inches in the Y. And that would be correct because we moved it upward by 4 feet. The other thing that I can find is what's the distance off the wall. You know, I was told to put it here, but how far does it sit off the wall? So if I use DI for distance, and I select the midpoint of the back of the sink perpendicular to the wall, that'll give me my distance at 5 1/8 of an inch. So again, I can use some of the inquiry commands to go in and locate ID points and distances in my drawing. And that's what you're going to be doing on the exam. In our final example, we need to step back from being the drafter designer to be the checker. And so let's use this example of how you would evaluate a simple part that would be very similar to what we would do in one of the exams. And I do want to call your attention to the measure tools, or as we call them, the inquiry commands, because that's what they were called years ago. So I can look at the distance or radius or angle, or we've talked about area, and use these commands. But I'm going to show you a few shortcuts to save time when you're taking the exam. So for example, if I'm asked, what is the center point of the large circle? What's the ID point? Well, I'm just going to type in ID, find the center, and at the bottom of the screen, there's my X and Y value. That saves me time. I could go into, turn on my properties palette, and if somebody says, well, what's the diameter of that circle? I can go ahead and select the large circle, go into properties, Control C, Control V, in other words, Control C to copy out of properties and drop it into the input box in the exam. What if I need to know the distance from the center of the large circle to the center of the small circle? Well, I can go in and I'll just type in DI, and I'll go from the center of one to the center of the other. And there I have my distance. So instead of going up to the ribbon, I'm just going to go in and type in ID or distance, or select my object. Now if I need to find the angle, for example, what is the angle from these two lines, I can go in and select that and I will get the angle. So I will go up to the Utilities panel and check out what the angle is of that object. So those are the ones that you will use. Use ID, use DI for distance, use the angle measurement if you need to know the angle measurement, and that will be able to help you answer many of the questions on the exams. And of course, if you need to find the area, you can use the area command, or as we showed you, just come in and hatch that object, select the hatch pattern, and it will give you the area of that part. So in conclusion, you are now able to develop your own workflow strategy for passing any of the Autodesk exams. We looked at some tips and tricks on how to do that. We went through some PowerPoints at the beginning, and we talked about studying only the objectives, and the objectives only. So we want you to remember to read all of the question and to read it slowly. To read all the possible answers before you make that correct answer. And also to look for distractors that'll take you off the question. And we talked about 4 possible answers for multiple choice. If you don't know, try to eliminate 2 that could be those distractors. We looked at phrasing, and this is where I said I have the most difficult, because sometimes I missed a word. It says, which are the valid ones or the true statements versus the invalid ones or the false statements. So take your time so you know which ones you're looking for, true things or false things in each question. Remember, the key was to, if you know it, you answer it. If you don't know anything about it, skip it. And if you're not quite sure, you put an answer, but you want to definitely come back to it, make sure you mark it in the exam. You want to develop that strategy for each question. And we did 10 hands-on exercises to give you an idea of workflow and the type of things that you will be looking for when we do the exam, based on the objectives for you to study. Now, I know we only got through 10, and there's more objectives on the exams, but you need to go back to the Autodesk website to make sure you study all of those objectives. And in closing, I want to thank you for spending your valuable time with us today, and good luck on passing the AutoCAD certification exams.